S. Chand presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now, in order to understand the position of shadow, how the position of shadow is altered with the position of sun. So that can be understood by using the diffraction pattern. So diffraction is basically bending of light. So when the position of sun is in front of us, so our shadow that is in the backward direction. When the position of sun is at backward to us, then our shadow is moving in front to us. So how the position of shadow is altered? So that can be understand by using the diffraction pattern. So myself Narendra Kaur, let us understand what is diffraction. If you want to study this topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now what is diffraction here? Diffraction is basically, it is a bending of light near the edges of obstacle or slits. That means the light get bent near the obstacle's edges. Now if there comes any obstacle in the path of light, then light get bent. Means if there is a light, we know that it will give us the light from the point. So the light is spreading all over there. Now there comes an obstacle. Now when the light falls over here, so this light will be trapped over here. Now at this point, at this corner, when the light is there, it will bend over here. Now this bending of light, that leads to diffraction of light. So the bending of light around the corner of obstacle and spreading into the region of geometrical shadow. We know that the shadow of this obstacle, that will be over there. Now the light bends at the corners. Here the light is bending of the light is taken place around the corner. And this light will spread in the corner of this geometrical shadow. So this spreading of light in the geometrical shadow, that is known as diffraction of light. So that means what is diffraction? That is a bending of light. Firstly, there is a obstacle or the slit must be present near the edges of the obstacle. So there must be obstacle or the slit that must be present in the path of light. Second one, there must occur spreading of light in the region of this shadow. We know that when the light falls on, now when there is a source of light, so firstly there are some requirements for the diffraction. Or you can say there is a requirement for the bending of light. Firstly, there is a need of source of light. Second, there is a need of slit on any obstacle. Third, there is a need of screen on which the diffraction pattern that can be obtained. Now, if there is a source of light, we know that from the source of light, the light is originating in the form of wavelets or the wavefronts. So that is given by the Huygens principle. So according to Huygens principle, each and every point on the wavefront that will act as a source of secondary wavelets. That means all these wavelets, they will superimpose on each other and we will get the resultant light from this source. So this is according to the Huygens principle. Now next, when any slit is present in the path of light. Now if there is a slit which is present in the path of light, now what will happen to the light over here? When we are seeing its normal picture, so in this case, here we are getting the shadow of this slit that is similar to over here when there is no light. But when the light is present in front of this slit, now there occur bending of light around the corner of the slits. So due to bending of light around the corner of this slit, so at this point we are getting the geometrical shadow of this light. So that means the light is spreading in the shadow of this slit or the shadow of this object which is placed in front of light. So that means in front of light, when the object is placed, what we are getting here? We are getting, that means that this narrow slit that will appear like here. Because why this is so? Because around this corner of this slit there occurs spreading of light. So that means that this is the width of the slit. So that will appear so much broad on the screen over here. So this kind of pattern, that is called diffraction of light. That means the light is bended over here. So this bending of light and spreading of the light, and the light is bended around the corner of the obstacle. Now this bending is taken place at the same angle from the both of the corners. So that is taken place at the same angle. Now this bending of light, and then again the light will get spread in the geometrical shadow. This is called diffraction over here. Again in the diffraction pattern, so what will be the diffraction pattern over here? So depending upon the conditions of maximas and minimas, we are getting here central maxima. Then there comes central maxima is known as a primary maxima over here. Then there comes another maxima which is called secondary. First secondary maxima. Then there comes second secondary maxima. Again in the opposite direction we are again also getting the secondary maxima first. Here the intensity of these secondary maxima is same on the both sides. So this is the diffraction pattern over here. Again there comes secondary, second maximas, and so on. In between there, some of the minimas are also obtained. Now on comparing this diffraction pattern with the interference pattern. Now what is the difference between these two patterns? We know that in the interference pattern with Young's double slit experiment, what we will get over here. So in the Young's double slit experiment, now if this is a central maxima, now that will be the position of another maximas on both sides to the central maxima. Now this is central maxima over here. Now that will be the positions of maximas on both sides. Now the intensity of these maxima, that is same. So that is a case of interference pattern. That means intensity of each and every maxima, that is same as that of central intensity. So that means here I0, I1, I2, they are same with each other. Their intensity is same. So this is the interference pattern. Now what kind of the diffraction pattern is obtained? So in case of diffraction pattern, if this is the intensity of central maxima, as you are moving from center to the position for the secondary maximas and the minimas, then the intensity of the maximas, that will goes on decreasing on both the sides. So this is a diffraction pattern on both sides over here. So that means the central maxima, that is of the maximum intensity, again for the first secondary maxima, its intensity is almost half to the central maxima intensity. So this is a diffraction pattern. So the difference between the diffraction pattern and the interference pattern is that in case of interference, we are getting the intensity on both sides that is equal to the central maxima for the another maximas. But in case of diffraction, what will be there? The maximum intensity for the central maxima is maximum. Again, for the another maxima, also for the minimum intensity. Here the intensity for the minima is not equals to 0. We are not getting a proper dark or proper minima in case of diffraction. While in case of interference, Dark means, minima means properly dark fringes are get obtained over here. Minima means there is zero intensity, or you can say that the zero amplitude waves are obtained. But here for the minimas, the amplitude is not equals to zero. So its amplitude that is not equals to zero. These are not known as zero amplitude minimas. So here the amplitude will be, there must be some amplitudes. So, and also for the maxima, intensity of the central maxima is maximum, and for the secondary maxima, its intensity goes on in decreasing on both the ends. So this is a diffraction pattern. So that is a difference between diffraction pattern and interference pattern. So due to this, why this is so? Because in case of interference, we are getting either constructive or destructive interference is done. Here in case of diffraction, after the bending of light, there occur again interference of light, because when the light get bent around the corner of obstacle, after the bending of light, each and every secondary wavelets, they get superimposed on each other. Means the diffraction result is also the combination of either the constructive interference or destructive interference. So depending upon that, we can calculate the position of maximas or the minimas on both sides to the central maxima. So where if this is the equal half, so in the central maxima on both sides, equal type of pattern that can be obtained. That means the position of this maxima and this maxima is same, and also their intensity is same. That means this central maxima is surrounded by two secondary maximas with the same amplitude and same intensity. This is also here, also the minima. Minimas on both sides, that will be also same. That means this central maxima is surrounded by two minimas on both sides. So this is a diffraction pattern in case of when the light get bending around the corners of an obstacle. Now let us take a short break. So till now we have studied what kind of diffraction is there, then the difference in the pattern of the diffraction and the interference. After the break, we will study two types of diffraction, that is the Fresnel and the Fraunhofer diffraction.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Before going to break, we have studied what is a diffraction, and that is a bending of light, and the difference between the interference pattern and the diffraction pattern. Now we will understand the two types of diffraction, that is a Fresnel and Fraunhofer diffraction. Now the diffraction that is of two types, one is a Fraunhofer diffraction and second one is a Fresnel diffraction. So what is a Fraunhofer diffraction over here? Fraunhofer diffraction is basically the difference between the Fresnel and the Fraunhofer is that the distance between the source and the screen. So this is a main part over here. So what kind of the incident source is used? So this is the first difference between the two diffraction patterns. So in the Fraunhofer diffraction, first in this case, this occurs when all the rays are passing through a narrow slit. That means when all the rays are passing through the narrow slits and the incident rays, that is, they are parallel to each other. Now how we can obtain this, the parallel pattern or the parallel rays over here? Then in order to get the diffraction pattern, first condition is that the distance between the screen and the source, that must be infinite. Means if this is a source over here, we know that we are getting a spherical wavefront from this source. Now if the slit is present over here, then the wavefronts from this source, they are spherical wavefronts. Now we want to convert this spherical wavefronts into the parallel wavefront, because in case of Fraunhofer diffraction, we are using a parallel wavefront. That means the light rays are taken parallel to each other. How we can get this parallel wavefronts? That means how we can convert this spherical wavefronts into parallel wavefronts. We know that now if this is spherical wavefront, the point source is used. So this kind of spherical wavefronts are used over here. Now when we see this spherical wavefronts from a very large distance, they are appeared as a parallel wavefront. So here they are the curve, that means the curve of these spherical wavefronts that goes on decreasing as soon as the distance from the source goes on increasing. So curve of these spherical wavefronts that will be decreasing over here. So that means we are placing this point source at the infinite distance such that the spherical wavefronts that will be appear as a plane wavefront. So the distance between the screen and the source, they are taken to be at the infinite distance. Now again, if this is the source over here and this is the screen over here, then this distance is also taken as equal to infinity. Again, how this can be done? So then again the parallel wavefronts that can be done by placing a lens over here. So when the lens is placed over here, that can be converted into the plane wavefronts. So the distance between the screen and the source, they is taken in order to make the parallel wavefronts. The parallel wavefronts that can be done because of point source, they are easily available to us. There from the point sources we are getting the spherical wavefronts. But in order to convert these spherical wavefronts into the parallel wavefronts, we are taking the source quite far away from the screen. When the distance is very large between them, so this spherical means curve of these wavefronts. So this curve of this spherical wavefront that will become or that will appear as a plane wavefront when this distance is very large. So if this is quite large over here, the curve of this spherical wavefront that will become almost plane wavefront. So this is a cost effective. In order to make this experiment cost effective, the distance between them is taken to be infinity. Second, the incident wavefronts that must be in the horizontal. Means horizontally the incident wavefronts are falling on the given slit. So this is the second condition. Third condition, the plane or the horizontal wavefronts are connected to each other by using the convex lens in order to produce a diffraction pattern. Now we want to produce a diffraction pattern. How that can be obtained over here? Firstly, the source is taken at infinity. So when the source is taken at infinity, the spherical wavefronts that can be converted into plane wavefronts. So these spherical wavefronts that can be converted into planar wavefronts when this source is taken at an infinite distance from the screen. Now this light is incident over here. Again we know that for the slit around its corners there occur bending of the light. So from these corners of the slit there occur bending of light. Due to bending of the light we will get the diffraction pattern on the screen this. So now after the bending of light from these corners, so at each and every point, so there occur, this is the bending of light over here. So that means at each and every point, what is the path difference between the two waves which are traveled over here? So that can be calculated by using or by dropping a perpendicular on each and every wavefront. Now we want to converge after the bending of light, all the rays, they can be converged or connected to one point. How you can connect these waves? So these rays, they can be connected with each other by placing a lens over here. When the lens is placed over here, the wavefronts of the light after the bending from each corner, now they can be converted to or connected to the one point over here. So this convergence of the light or how the light waves, they can be connected to each other, that can be done by using a lens in this case. Again, at the central point, so if this is the central point over here, then at the center point, all the rays, they can be connected to each other by using the lens. Because if the lens is not used in this case, we are not able to connect the light over the screen. So that cannot be done. Now if this is a screen over here, and that is a lens, means without lens, the light cannot be get converges to the one point. Now again, at the central point, the whole of the light, that is get converted or that is get connected over here. So when the whole of the light is get connected at the single point, that will be the condition of maximas. So that means this is a condition for central maxima. So central maxima will be formed over here. Again, now if this is the point P over here, now at the point P, either minima or maxima, that can be formed. How the minima or maxima which are formed at point P? Now for this we will calculate path difference between each and every ray. So the path difference is calculated. Now if this path difference, now if this angle is theta for each and every ray which is making at an angle theta. So now the path difference between, if we are taking the last two rays, now if this is a point S, this is a point S dash, and that is a point P, and this is a point Q over here, then the path difference between SP and S dash P, the path difference between these two rays, that is equal to S dash into, if this is a Q point here, S dash Q point. Now depending upon the path difference, if this path difference equals to integral multiple of lambda, then that will be the condition of maxima. And if this path difference is equals to or multiple of lambda, or you can say that integral multiple of lambda by 2, then that will be the condition for minima. So depending upon that, we are getting either maxima or minima. So this is the Fraunhofer type of diffraction. Okay, now next is the Fresnel diffraction. So what is the main condition for the Fresnel diffraction is that the distance between the source of light and the screen, that is finite with each other. So here the distance is taken finite in order to get the diffraction pattern. So distance is a finite over here. So that means the wavefront falling on the slit over here, that can be spherical wavefront. The main condition is that the distance between the screen and the source, they are near to each other. That means here the distance between them is not very large. So this distance is finite, that is a measurable condition. So the shape of the incident wavefront, that can be either spherical or cylindrical. Now if we are using a point source, then wavefront that can be spherical. Now if you are using a plane wavefront, a plane source of light, then the wavefront that can be cylindrical. So depending upon the shape of the source, the wavefronts that can be spherical or cylindrical. Then the objects left by the wavefronts, they are spherical. When the spherical wave light, as the spherical light is falling on the object shape that will be appears to be spherical to us. Then next, the lenses are used in order to converge the light over here. So now we know that here in case of Fresnel diffraction, so this is a spherical wavefront over here. Again, this is a slit in this case, around which there occur bending of light. Now in order to converge the light from source to the slit, so one lens is placed over here. So due to this lens, this wavefront, the wavefront that is spherical. This spherical wavefront that will be falling to the slit by using a lens over here. Then after the bending of light, now in order to convert or in order to connect or converge the radiations on the screen, so the light is get converged on the screen by using another lens over here. So these lenses are here not used to convert the light into the parallel beam, but they are used to converge the beam over the slit and over the screen. Now again, after the bending of light, we will get here diffraction pattern. So the diffraction pattern of light that can be obtained in this case. So now this diffraction pattern, now this is again the point of central maxima and minima. So the main difference is that the source and the screen, they are at finite distance, and the diffraction pattern on the screen, again depending upon the path difference, whether the path difference is an integral multiple of lambda or that is odd multiple of lambda by 2 or integral multiple of lambda by 2. Depending upon that, we can get the principal maximas and the secondary maximas on the screen. So this is a main difference between the Fresnel diffraction and the Fraunhofer diffraction. So here we understood what is the difference between the Fresnel diffraction and the Fraunhofer diffraction, and how the diffraction is taken place and the light is get separated in the geometrical shadow. Thank you. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe the this video, and also you can press the bell icon for the future notification.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.